In this video, we are going to create normally distributed random numbers and to fit curves to the normally distributed random numbers. Kindly watch this video up to the end so that you could understand and learn the whole process. Let me start with the introduction. What is the randomly normally distributed function? The random normal function in R is a very powerful built-in function which is used for creating random numbers. The R function, denoted by R norm, is used for creating a vector of random numbers with a normal distribution. This distribution is useful in statistical research due to its bell-shaped curve. The primary goal of the R norm function is to generate data points that mimic the typical patterns observed in the real-world events. We may use the following syntax: R norm within parentheses n for sample size and mean equals 0 and standard deviation equal to 1. These are the default numbers for mean and standard deviation. In this syntax of the R norm function, the different parameters are as follows. N represents the number of random values to generate. Mean signifies the mean or average of the distribution with a default value of 0. Similarly, SD denotes the standard deviation, indicating the spread of values with a default value of 1. This is an example. We may create data frame. A is randomly normally distributed with n equal to 2000, mean of 55 and standard deviation of 19. Similarly, B is another random normally distributed vector of numbers with the number of observation equal to 2000, mean equal to 65, standard deviation is equal to 15.5. and similarly we also may have C and D. So there are A, B, C, D randomly distributed normally distributed random numbers. And if we write head within parentheses data, then it will show us the first 6 observation of these 4 created variables. Now let me open my R, and first of all I will open new file script, and here I have 4 different areas. This one is the editor window, this one is the console area, this is the global environment, and below here this is another window for displaying curves that will be shown with this data. So let me first start with the generation. So first of all I would like to generate normally distributed random sample of 50 numbers. So I created this. Now let me print these numbers with you, and these are exactly let me print this. Now these are the 50 values that I just generated. Let me also specify. Now I am going to generate normally distributed random numbers. N is equal to 50, but this time I specify that mean should be equal to 50 and standard deviation should be equal to 10. Previously in these values the mean by default was 0 and standard deviation was equal to 1. Now this time I specify standard deviation as 10 and mean as 50. If I run this, so random numbers 1 have been generated. Let me print, and now this time these are the 50 normally distributed random numbers with a mean of 50 and standard deviation of 10. Now let me repeat this again, but I name this as 1 1 instead of 1, So n is again 50, mean is again 50, and standard deviation is again 50. So if I do this, it will create another set of random numbers with the mean of 50 and standard deviation of 10. So here these numbers have been generated, and now let me share with you its print. Now if I print this, now these are also 50 numbers which are normally distributed random numbers. Mean is again equal to 50 and standard deviation is equal to 10, but the two sets of random numbers is different. For example, here in the previous set we had this value as 49th value was equal to 65.77. Here the 49th value is 53.02. So every time we repeat this experiment, these random numbers will be different. But if you want to have exactly the same numbers that you generated, then you will have to use this command, set seed. Say for example, I set this seed as 1, 2, 3. Now after this, I want to generate 50 random numbers that are normally distributed with 0 mean and standard deviation of 1. So by clicking run, these random numbers have been generated. Let me share with you these numbers. Now these are 25 random numbers. These are normally distributed around its mean value of 0 and standard deviation of 1. If I set seed again to 1, 2, 3, and I use the same command as I did earlier, then exactly the same numbers will be generated that I just did before. And I can show it to you. For example, previously the 25th value was minus 0.62, and again here it's also equal to minus 0.62. This is because of setting seed. Similarly, I set again the seed to 1, 2, 3, and I repeat the experiment, the same experiment that I did here and here. Now I repeat the same experiment. So if I print, these number will be exactly the same that we generated before. So if you look at these numbers, they are exactly the same, and these are exactly the same as these. So by using this command set seed, we will generate exactly the same set of random numbers. Now let us suppose I want to create another sequence of random numbers from where the x values varies between minus 3 and plus 3, and the difference between various value is 0.1. So if I run this, x series have been generated. Now let me create another value, another variable y. Its mean is 0 and standard deviation is equal to 1, and this is equal to x. So now another random number has been generated, which is normally distributed with mean of 0 and standard deviation of 1. Now let me plot this. So this is the plot of the y against x. So it means x is normally distributed with 0 mean and standard deviation of 1. Let me run this command. So this is the normal plot of these two variables y. This is the probability and this is the x. After that, let me create another normal curve, and let us suppose I want to create a random number normally distributed random number between 35 and 65. So I'll create this sequence. X is equal to sequence from 35 to 65, and the difference between two different values is equal to 0.1. So here X has now regenerated. Similarly, I want to create Y. So these values have now been renewed, and now I would like to plot X against Y. So this is the plot of Y against X, and it says X is normally distributed with mean of 50 and standard deviation of 5, and I can also specify AB line at the value of 50, and if I want to change the color of this AB line, so this is the command. So this is the AB line at the X value of 50. After that, let me change the values of X from 35 to 65, and instead I am using these values. The lower value is 30 and the maximum value is or the higher value is 70. So let us see how this distribution will change now. Let me do this, and now let me plot this. So you will see this curve will change. You can see when I change the lower and the upper limit of X variable from 35 and 65 to 30 and 70, the normal distribution shape changed like this. I can also create AB line, and I can change its color to red. So this is how we can play with this. Now let us suppose that I make it again the original one. The lower value is 35 and the maximum value is 65, and standard deviation is equal to 5 and mean value is equal to 50. So this is its normal curve. So this is just like the earlier one that we did earlier with the data with lower limit of 35 and upper limit of 65. Now I want to change the color of the AB line to red. Now I just want to change or decrease the standard deviation. I am using the same data set, 35 lower limit, 65 upper limit, but instead of standard deviation equal to 5, I want to use a standard deviation equal to 1. So let me see what happens. Now by changing the standard deviation from 5 to 1, which means reducing the size of standard deviation, this normal curve will change its shape. See how the shape of the normal curve changed when we reduce the value of standard deviation from 5 to 1. I also want to create AB line with a red color. So this is the AB line. Now let me increase the size of standard deviation from 1 to 7. So I want to change standard deviation to 7, and let me also show you the plot. Now by increasing the standard deviation, the shape of normal distribution changed like this. I can also change the I can also change the color of AB line to be red, and similarly I can also estimate or compute probabilities for the sequence of x between -3 to +3, and the values are different by 0.1 with d norm x, mean of size 0 and standard deviation of 1. So let me highlight both of these and show you this. And after this I want to plot this, and let me make the color. Okay, now I want to calculate probability when x is equal to 0 and the mean of the distribution is equal to 0 and standard deviation is equal to 1. So the probability for this is equal to 0.1. Now if I want to check the probability when x is equal to 0.24, then what will be the probability? Then the probability of x to be equal to 0.24 is equal to 0.5948349. So my dear students, colleagues and friends, this is how we can generate normally distributed numbers with different values of sample size, mean, standard deviation, and then we can create normal curve to fit these random numbers, and finally we can also compute probability values for these random numbers. Thank you very much for watching this video. Kindly share this video with your friends, with your colleagues, and subscribe to the channel. Don't forget to click on the bell icon so that you can get timely notification about my other videos that I'll